So, O God Almighty, Lord us, loving children, cover today our works and studies. Help us, your Lord, to have our teachers and schoolmates to be diligent in our studies, that we merit the blessing for ourselves, our parents, and all humanity. Amen.
Good afternoon, class.
Good afternoon, ma'am.
So before you take your seats, let's have first an energizer. Are you all familiar with the song I'm Alive, Alert, Awake?
Yes, ma'am.
Okay, let's do the I'm Alive, Alert, Awake song with action. In 1, 2, 3, go! I'm alive, alert, awake, enthusiastic. I'm alive, alert, awake, enthusiastic. I'm alive, alert, awake, alert, alive. I'm alive, alert, awake, enthusiastic. Okay, faster. I'm alive, alert, awake, enthusiastic. I'm alive, alert, awake, enthusiastic. I'm alive, alert, awake, alert, alive. I'm alive, alert, awake, enthusiastic. Okay, very good. So I hope you feel alive, alert, awake to listen to our new discussion today. Before anything else, pick up some pieces of paper and you can now take your seats. Okay, let us check first the attendance. Who is the class secretary? Okay, Miss Precious, kindly list down the absent for today and give it to me later. Okay, yesterday I give you an assignment. I am right?
Yes, ma'am.
Okay, so pass your paper in 10, 9, 8, 7, pass it forward, 4, 3, 2, 1, go. Okay, thank you very much. So this time, okay, class. Who among you here remember our last topic, class meeting? Our last topic is all about eigenvectors and eigenvalues. Okay, Mr. Noel, what is eigenvector?
So, eigenvectors are the vectors non-zero that do not change direction when any linear transformation is applied.
Okay, very good. So, what is eigenvalues? Miss Suman.
So the eigenvalue is a scalar that is used to transform the eigenvector. The basic equation is Ax is equals to u times.
Okay, very good. By the way, why are you not wearing your uniform?
Ma'am, I wasn't able to wash my uniform.
Okay, so next time you wash your uniform early so that you will go to school with your uniform. Okay, I will not let you in next time. Okay, so let's give them a round of applause for they know what is the meaning of eigenvectors and eigenvalues. Class, before we are going to proceed to our proper discussion, I will introduce to you first my classroom rules so that we will have a smooth and organized learning environment. So these are my classroom rules. Kindly read everyone loud and clear. 1, 2, 3, go!
Classroom rules. Be your best. Be ready to learn. Be honest and helpful. Respect yourself. Respect your classmates. Respect your environment. Do listen to your teacher. Do follow school procedures. Raise your hand. Raise your confidence. And raise your expectations.
So I hope you come to school and you are ready to listen and to learn our new topic today, and I hope you will respect everyone, including your classmates, as well as your teachers and everyone, and of course, follow instruction, whatever instruction I will impose to you, you will follow it, and above all, if you want to answer, what will you do? Raise your hand. And now, I will introduce to you the incentive chart for you to feel motivated during the process of our discussion. So now, I will group you into two. Okay? Miss Tome and Miss Tomojo will be group 1. So you will be with Miss Tomojo, Miss Tome, and the rest, Precious, Noel, and Ryan will be group 2. Okay, understand?
Yes.
Okay, so this incentive chart, diba you have your groups na? Okay, you already have your group, so whatever question I will ask to you, and if your group answers it, then you will gain points by stepping forward. So this is the starting point, group 1, and then group 2. for example, I will ask someone, what do you mean by matrix? So if the group of Miss Tome will answer, then if they got the correct answer, they will step forward. Then 1, up to they finish, up to they get the finish line. The first group who will arrive here, the endpoint will receive a reward after the class discussion. Am I clear?
Yes, ma'am.
Do you understand?
Yes, ma'am.
Okay, are you now motivated to learn?
Yes, ma'am.
I can hear you.
Yes, ma'am.
Okay, yes, ma'am. That's very good. Do you understand now my classroom rules and of course how our incentive chart works?
Yes,
Are
ma'am.
you now ready?
Yes, ma'am.
I can hear you.
Yes, ma'am.
Okay, that's very good. That's the spirit. Now, let's go to our motivational activity. Do you know what is crossword puzzle?
Yes, ma'am.
Did you already do it?
Yes, ma'am.
Okay, Mr. Ryan, how did crossword puzzle work? You can answer in Tagalog.
So, there are given letters from them. All we have to do is just to complete the letters with the correct words.
Okay, very good. Let's give Mr. Ryan a very good clap. 1, 2, 3, go. 1, 2, 3, 1, 2, 3. Very good, very good, very good. Okay, that's a point for group 2. Okay, group 2 will now move. Step forward, group 2. Okay, group 1, I know every time I ask, you will answer so that your number will step forward. Okay, now this is my crossword puzzle that I prepared to you. But the twist is, all of you will answer on the board and write the correct answer here on the prepared chart. And then you pick the definition here, and whatever number you will pick, you will answer. That's the number you're going to answer. No need pass. Pass is not required. You need to pass. So whatever number you will pick, you will answer it. Okay, understand?
Yes, ma'am.
Okay, before anything else, go with your group. Sit with your group. Okay, Miss Precious, you can sit at the back. Okay, and Miss Tome and Miss Tumudu will sit beside each other. Anything else? Group 1, may I hear your loudest cheer? How about group 2? Wow, very good. I feel like you are very prepared for this afternoon. So, sino ang mauuna? Oh, very good. Okay, Miss Precious, group 2 will go first. Okay, kindly pick a strip of paper here and write the answer on the chart.
5.
Number 5. Okay, kindly read aloud what is the definition written on that strip of paper.
A square matrix in which all the elements of the principal diagonal are ones and all other elements are zeros.
So, what do you think is the answer? Number 5.
Identity matrix.
Why do you say so? That it is identity matrix. So what is your clue based from the given definition?
I know. All the elements are the diagonal
And
the remaining elements are zeros.
okay, very good, Miss Precious. So you can now write the identity matrix on number 5. Identity matrix. Okay, group 1, do you have any other answer? Okay, now so you are agree with identity matrix.
Yes, ma'am.
Okay, let's see. So identity matrix is a square matrix which all the elements of the principal diagonal are ones and all the other elements are zeros. So identity matrix is correct. So let's clap our hands for group 2. Okay, Miss Precious, kindly move your number here on our incentive chart. Okay, group 1, it's your turn. Group 1, it's your turn. Kindly take a strips of paper. Okay, what do you think is the answer for number 1?
I think it is vector, ma'am.
Why do you say so vector? What is your hint or your clue?
It is stated here that it is represented when our whose direction is the same as of the quantity and whose length is proportional to the quantity's notation.
Okay, so do you think that is vector? So write vector here if that is correct. Okay, group 2, do you have any other answer?
None, ma'am.
Okay, none, but I guess vector is correct. And finally, group 1 will move forward. So before anything else, let's give them a round of applause for group 1. Okay, Miss Mojo, kindly please move your number here on the first. Okay, next, we have group 3. No, we don't have group 3. Of course, group 2. Group 2, Ryan, go. Kindly read it loud and clear in front of your classmates.
So number 2, a two-dimensional set of numbers or symbols distributed in a rectangular shape in vertical and horizontal lines so that their elements are arranged in rows and columns.
So what do you think is the answer? Number 2.
So I think it is matrices.
Matrices, why do you say so?
So according to this definition, it's distributed in a rectangular shape in vertical and horizontal lines, and as what I have learned, it is called matrices.
Okay, matrices, so write matrices there in number 2. Matrix. Okay, and can you please draw an example of a matrix? Okay, is Ryan correct?
Yes.
Why are you so quiet? Is Ryan correct? Loud. Is Ryan correct?
Yes.
Okay. Yes, Ryan is correct. And Ryan, please move your number there in the incentive chart. And let's give them a 5 claps. 1, 2, 3, go. Okay. Let's move forward to the remaining strips. Okay, group 1, your turn. Okay, group 2, minus. No, it's warning because your group is very, very noisy. You keep talking. Go.
It is a line segment connecting the opposite vertices or corners of a polygon.
So what do you think it is? A line segment. Diagonal. So write the word diagonal at the back. Is Miss Tome correct or wrong?
Yes.
Yes, I'm correct, ma'am.
Correct? Okay, yes. Miss Tome is absolutely right. So Miss Tome, move your number there on the chart. Okay, Mr. Banaag, it's your turn because you keep talking at the back. Okay, the last trick, I guess. Read it loud and clear in front of your classmates.
It is a branch of mathematics that concerned with mathematical structure close under the operation of addition, scalar multiplication, and that includes the theory of system of linear equation matrices, determinants, vector space, and linear transformation.
So what do you think is the answer? What branch of mathematics is being defined there?
I think, ma'am, it is linear algebra.
Okay. Write the word linear algebra there. Okay, is Mr. Banaad correct?
Yes, ma'am.
Okay,
Yes, ma'am.
Okay, because of that, we will have an activity related to our new topic. Okay, did you sit with your group already?
Yes, ma'am.
Okay, our activity for this afternoon is called Gallery Walk. But before anything, I will get Gallery Walk. So, do you know what is Gallery Walk? Anyone? Did you have an idea? What is
No, ma'am.
Gallery Walk? So, our activity is called Gallery Walk. So, inside this classroom, at the back, I prepared some pictures. Or this time, you will experience how... Okay, class, did you already experience this activity?
No, ma'am.
Okay, that's great because gallery walk, you will experience like you are walking in a museum and you will see many pictures, painting. But this time, at the back, I prepared a lot of pictures, but not a painting. It is a pictures about matrices, about mathematics that is connected to our new topic this afternoon. So, are you ready?
Yes, ma'am.
Again, are you ready?
Yes, ma'am.
So while you are doing this, I will only give you 10 minutes. Or I will only give you 10 minutes. So while you are doing the activity, after that you will share to it to your classmates, to your group mates, what did you observe from the pictures that I posted at the back. So are you ready?
Yes, ma'am.
Okay, your timer starts now.
Square matrix is all the diagonal are 1 and then remaining are 0.
Okay, class, time is up. You may now go back to your seat. Okay, go back to your seat already and sit with your group. Okay, this time, it's time to share your experiences and of course your observations based from the pictures posted at the back. So, group 1, who can share?
Based on my observation, Mamas, I've seen an example of diagonal matrix.
Okay, you've seen an example of the diagonal matrix. Very good. How about the other group?
So, we have seen there symmetric matrices, but we don't have any idea about it.
Okay, that's very good observation. Okay, others, what can you share, Miss Tome?
We have seen also about the examples of matrices.
Okay, very good. So anyone? Okay, Mr. Ryan.
So, I have observed, ma'am,
Wait
na...
na, itas na. Dito to naman ako sa playing a video.
Ala, wait.
Ala,
Uy, good din na, magtubag sila na ako kayo para mag-apat sila sa atong ano, dito sa papasunda.
Hindi man. 1, 2 na sila. So, 1, 2, sumpay na. Uy,
Si Precious mo lang isa. Dapat din sila daw.
okay ba na? Uy, ano dahil maging anak? Oh!
Ano nakaway mo?
Ikaw!
Matulong ka sa bitin, pre.
Sige. Sige. Hindi nila. Okay, sige na.
Balik sa ulit.
Ano sa pag-grabe nila?
Tangan.
This time, it's time to share your experiences and of course observations based from the pictures you've seen at the back. Okay, group 1, please share your observation.
So, based on my observation, ma'am, I've seen there a sample of diagonal matrix.
Okay, you've seen an example of diagonal matrix. Very good. How about
So,
group 2?
our group seen a lot of examples, but the only one that catches our mention is the word symmetric matrices, but still we don't have a idea about it.
Okay, thank you very much for that very good observation. Okay, another. Miss Tome?
And also we have seen some examples of matrices.
Okay, very good. So, because you answer my questions, group 1, you will move forward 2 steps forward. And of course, group 2, 1 step forward. So, the leading again is group 2. Okay, based from our activity called Gallery Walk, what do you think is our topic for this afternoon? You've seen a diagonal matrix. You've seen a symmetric matrix. You've seen a lot of examples of matrices. What do you think is our topic for this afternoon? Okay, Miss Tome.
I think our topic for this afternoon is about the diagonal.
Okay, about diagonal, and Miss Tome have a point because this afternoon we will study about diagonalization. Okay, Miss Tome, can you move forward your group there and then start the chart? And this time, group 2 and group 1 are in the same spot. Okay, who will win this reward that I prepared to you? This afternoon, we will talk about diagonalization. Okay, are you familiar with this word?
No.
Exactly because we didn't discuss it yet. So for today's discussion about diagonalization, these are our objectives that we will be needing to meet at the end of that discussion. Okay, group 1, kindly read this part. Objectives, 1, 2, 3, go.
Objectives. At the end of the lesson, the learners are expected to
Everyone, please read letter A.
determine whether a given matrix is diagonalizable, symmetric, or orthogonal.
Group 1.
understand the concept of diagonalization, symmetric, and orthogonal matrix. And
Group 3, Group 2, by the way.
So the diagonal, symmetric, and orthogonal of the given matrices.
Okay, so these are our objectives that at the end of the lesson, we are hoping that we will be able to meet all of these. So, are you ready for
Yes.
our discussion?
Yes, ma'am.
Okay, diagonalization. Kindly read, Ryan, what is diagonalization?
Diagonalization involves taking a matrix and writing it as a product of a matrices, one of which has only values along diagonal.
Okay, diagonalization. When we say diagonalization of a matrix, it involves taking a matrix and writing it as a product of a matrices, one of which has only values along diagonal. If we are going to diagonalize a specific matrices, and of course the matrices that is only and can be diagonalizable is a square matrix. So when we say square matrix, it has an equal number of rows and equal number of columns. So example, 2 by 2 matrices, 3 by 3, 4 by 4. So that is the matrices that we can only diagonalize. So along with the lesson, you will encounter the formula that we are going to use in order for us to come up and in order for us to diagonalize a specific square matrix. So if we are going through the process using that formula, and if we come up with the same matrices given, then that will state or that will prove that the given matrix is diagonalizable. For example, we have a Precious, can you give me a 2 by 2 matrix?
A is equal to 2,
2,
5,
5,
6,
6,
9.
9. Okay, for example, this one. This is an example of 2 by 2 matrices. And 2 by 2 matrix is an example of a square matrix. So along with the process, we will use a specific formula. And if we use that formula that I will be introducing diagonalization. Stop sa tira. So this is the formula for in performing diagonalization. The formula in performing diagonalization is A is equals to x times dx raised to -1. So the example on how to perform diagonalization on a given matrix is this. So for example, we have matrix A which has -3, -4, 5, and 6. The first thing we should do is to find the eigenvalues. Last meeting, we already discussed on how to find the eigenvalues by using this formula where A minus lambda I is equals to 0. The next thing we should do with this formula to find the eigenvalues is to subtract lambda I on the diagonal of it. So, -3 minus lambda, -4, 5, and 6 minus lambda equals to 0. So, that's how we do it. We should copy. Next thing we should do is to get the determinant. So, -3 minus lambda times 6 minus lambda and minus -4 times 5 is equals to 0. So we should always consider that the determinant will be always equal to 0 for diagonalization. The next thing we should do is to do a FOIL method on this specific area. So the come up of this is -18 plus 3 lambda minus 6 lambda plus lambda squared, and of course -4 times 5 would be -20, and -20 times this negative sign is positive 20 is equal to 0. Then we will be going to simplify it, and the come up of this answer is lambda squared -3, because -6 plus 3 would be -3 lambda plus 2, because 20 minus 18 is equals to 2 is equals to 0. Now, the answer for this one, which is lambda squared minus 3 lambda plus 2 is equals to 0, we will factor it out. So the factor of this equation is lambda -1 times lambda -2 is equals to 0. Therefore, lambda 1 is equals to +1 and lambda 2 is equals to +2. Now, this is our eigenvalues, which is 1 and 2. Now, let's proceed to the formula of performing diagonalization. So, this is the eigenvalues, which is 1 and 2. And now, let's get the eigenvectors. So, let's proceed in getting the eigenvectors. So, we will use the formula. This is the formula lambda I times surface is equals to 0. So let's find the lambda 1, which is A minus, which is our lambda 1 is equals to 1. Therefore, 1 times the I, which give us, we will write the given matrix, which is -3, -4, -5, and -6 minus the identity matrix, which we will use the number 1. So 1, 0, 1, and 1. So if we subtract this given matrix from the identity matrix, this will give us -4, -4, and 5, and 5. So with this, the eigenvectors of this one is equal to -1 and 1. So let's proceed to lambda 2. So A minus 2 identity is equals to the given matrix is negative 3, negative 4, 5, and 6 minus which is identity matrix 2, 0, 0, and 2. We are going to subtract the given matrix to its identity matrix which has is lambda 2. This will give us an answer of negative 5, negative 4, 5, and 4. So the eigenvectors for this is equal to negative 4 over 5 and 1. So now we already have the eigenvalues and eigenvectors. Let's perform diagonalization. So now that we have already our eigenvalues and eigenvectors, for vector number 1, number 2 is equals to negative 4 and 5 and 1. Let's perform diagonalization to get that D. So this means that D is equals to, we just put the value of the lambda. So 1, 0, 0, and 2, and 1. So D is the matrix which is the diagonal is the eigenvalues along with 0. And X is the matrix which includes the eigenvectors. So it is negative 1, negative 4, and 5. So we just have to form it like this. So 1 and 1. So since we already have the value for D and the value for X, we only need to find the inverse of this one. So since this is a 2 by 2 matrix, we will get its determinant. We will just have to swap the diagonal. So negative 1 would be 1 and negative 1 and negative 4 over 5 and 1. Times, I will just write it again. So 1, negative 4, and 5 times 1, negative 1 times 1 over its determinant, which will gives x is absolute of x is negative 1 times times 1 minus 4, negative 4 over 5 times 1, which has the answer of negative 1 plus 4 over 5 and equals negative 1 over 5. So negative 1 over 5 is our determinant. So since the determinant is negative 1 over 5, we will just have to perform this one. So 1 negative 4 over 5 times 1 negative 1 times 1 over negative 1 over 5, or we just simply divide it by negative 5. That will come up to negative 5, negative 4, 5, and 5. So since we already have the components that we needed in order to diagonalize A, so we have the given negative 3, negative 4, 5, and 6, which is that we have the diagonal 1, 0, 0, 2, and we already have the x, which is negative 1, negative 4, and over 5, 1, and 1, which is, this is the eigenvectors, and these are the eigenvalues which we put in the diagonal. And of course, we already come up with of x, which is negative 5, negative 4, 5, and 5. And now, let's do the formula, which is A is equals to x times D times x inverse. So we have to multiply the 3, which is the x is negative 1, 1, negative 4 over 5, and 1 times the diagonal 1, 0, 0, 2 times the inverse, which is negative 5, negative 4, 5, and 5. So the first thing we should do is to multiply this one. So the first thing to multiply is this 2, the d and the x inverse. So just copy the x, which is -1, -4 over 5, 1, and 1. And the product of this one is -5, -4, 10, and 10. Now, we will be multiplying the x by the new matrix, which is the product of the diagonal and the inverse of matrix, which will give us A is equal to 5 minus 4 over 5 times 10, 4 minus 4 over 5 times 10, and -5 plus 10 and -4 plus 10. So if we're going to simplify this one, this will give us -3, -4, 5, and 6, which is the identity or the same as the given matrix. So that's how we form diagonalization. So let's proceed to symmetric matrix. So when we say symmetric matrix, in linear algebra, is a square matrix that remains unaltered when its transpose is calculated. That means a matrix whose transpose is equal to the matrix itself is called a symmetric matrix. So it is mathematically defined as follows. First, a square matrix B which of size n times n is considered to be matrix if and only if the transpose of it is equals to B. Consider the given matrix B that is a square matrix that is equal to the transpose of that matrix called a symmetric matrix. For example, matrix A is equals to 1, 2, 3, 2, 1, 3, 1, 2, 3. If we are going to perform the transpose of a matrix, it will be 1, A transpose is equal to 1, 2, 3, 1, 2, 3, 2, 1, 3, and 1, 2, 3. Are they the same?
No, ma'am.
That means this is not a symmetric matrix. Okay, let's say for example, another example is this. 1, 2, 3, 2, 1, 3, 3, 2, 3, 3, 3. Okay, if we are going to get the transpose of it, it will become 1, 2, 3, 2, 1, 3, and 3, 3, 3, 3. Are they the same?
Yes, ma'am.
So that means this is a symmetric matrix because when we get the transpose of it, it will give the same matrix which is given. So this is the example of symmetric matrix. Now let's proceed to orthogonal matrix. So orthogonal matrix. The matrix is said to be an orthogonal matrix if the product of a matrix and its transpose gives an identity value. So before discussing it briefly, let us first know what matrices are. A matrix is a rectangular array of numbers which are arranged in rows and columns. So we know that a square matrix has an equal number of rows and columns. A square matrix with real numbers or elements is said to be an orthogonal matrix if its transpose is equal to its inverse matrix. Or we can say when the product of a square matrix and its transpose gives an identity matrix, then the square matrix is known as an orthogonal matrix. So suppose A is a square matrix with real elements and of n times an order, and A transpose is the transpose of A. Then according to the definition, if A transpose is equals to A, its inverse is satisfied, then A times A transpose is equals to I. Okay, class, do you have any question regarding our topic about diagonalization and determining whether the given matrix is symmetric or orthogonal?
None, ma'am.
Do you have any volcanic eruptions?
None, ma'am.
Okay, none? I guess you really understand our topic. So this time, I will giving you a group activity and all you have to do is to answer it in 5 minutes. Okay, group 1, this is your question. And group 2, kindly get this. You are only given 5 minutes to solve the given matrix. So for group 1, you will be solving if the given matrix is an orthogonal matrix. And group 2, you will be solving the symmetric matrix of the given matrix. Understand?
Yes, ma'am.
No questions?
None, ma'am.
Am I clear?
Yes, ma'am.
Okay, your time starts now. Okay, time is up. Pass your activity. Pass your activity. Group 2, faster. 1, 2, 3. Okay, I hope that you get the correct answer. Okay, this time, because you already know what is diagonalization, what is symmetric, what is orthogonal matrix, we will be going to do an evaluation if you really understand the topic. So are you ready?
Yes, ma'am.
I'll get 1/4 sheet of paper. No, 1 rule because test 1 and because for items number 1 and 2 it's only a multiple choice. 3, 4, and 5 you have to solve it. Okay, get 1 whole sheet of paper. Okay, are you ready, class, to take the evaluation?
Yes, ma'am.
Okay, and I hope you will really get a high score. For question number 1, 30 seconds. Write only the letter of the correct answer. Question number 2. Okay, question number 3. Okay, question number 4. Number 5. Okay, time is up. Time is up. Class, exchange your paper with your seatmate. For number 1, Miss Tome, kindly answer.
It is a square matrix that remains unaltered when each transpose is calculated.
What do you think is the answer?
Symmetric.
Okay, very good. So, symmetric is the correct answer. And group 1 will proceed now.
Symmetric, ma'am.
Yes. Okay, who got correct? Number 1. Okay, Ryan. Okay, I thought you're wrong. Okay, number 2. Kindly read, Ryan.
The matrix will be an orthogonal matrix if letter A, ma'am. The product of matrix and its transpose gives an identity value.
Okay, very good. So number 2 is letter A, and group 2 will move forward. Okay, number 3, Banaag.
Find the symmetry of the given matrix. So, ma'am.
Yes.
The word, ma'am. Orthogonal.
Okay, yes, that is an orthogonal matrix, and kindly check the process of your classmates. If you come up with the same matrices of the given, then that is an orthogonal matrix. Who got correct? Okay, because all of you got correct, I will move your number here. So the leading is group 2. Okay, for number 5. Perform diagonalization. Okay. Check your answer, check your classmate's answer if his or her answer is correct. So the correct answer for that is this. Wait lang. So this is the correct answer. Kindly check the answer of your classmate. Okay. Did you arrive with the same answer?
Yes, ma'am.
Okay, who got perfect? Okay, and please move forward your number on the incentive chart
How
after
many,
the
ma'am?
last one because you got perfect. Yes. Number 2.
Yay.
And the winner for our treasure hunting is group 2 because I already gave a chance for group 1 to put their group on the last spot, but then they end up only there. Okay, that's all for our evaluation, and this is your assignment.
Kaya pa na, guys.
Balik ka ng video.
Expectation versus reality measurement kayo kami. Okay,
Okay, class, that's all for today.
Balik sa akin.
Okay, class, that's all for our evaluation. Congratulations, everyone, because you got a perfect score. And of course, congratulations for Group 2 because they win the activity. Okay, Group 2, kindly claim your reward next meeting. For your assignment, everyone, please read your assignment. No, wait. Okay, everyone, please read your assignment.
Do an advanced study about the orthonormal basis.
Okay, do an advanced study about the orthonormal basis because next meeting we will discuss about orthonormality. Okay, that's all for today. Pick up pieces of paper, fix your things. Goodbye, class.